Welcome viewers. In this video we'll see the AC terminology. First we'll see the waveform. The waveform is nothing but the graph drawn between the alternating quantity with respect to the time. The waveform is the important term in AC terminology. In case of DC, the voltage or current is always constant, direct current, always constant irrespective of the time. For the given time, for any time, the voltage is constant in case of DC. But in case of AC, alternating current means it is keep on alternating, that is changing from positive to negative with respect to time. So the waveform is very important in case of AC terminology. The alternating quantity may be either voltage, current or flux. We can take either voltage or current or flux. There are so many type of waveforms available. We will see these waveforms one by one. Let us assume that the alternating quantity is voltage. The alternating quantity may be voltage, current or flux. Here we assume that we will take the voltage as a reference. First we will see the sinusoidal waveform, sine waveform. So this is a graph drawn between time and voltage. You see that from 0 to pi the voltage is positive. From pi to 2 pi the voltage is negative. So we have positive cycle and negative cycle, alternate. The voltage is alternate between positive to negative. From 0 to pi means 0 to 180 degree, the voltages keep on increases, reaches the maximum value, again decreases, again reaches the 0 value. It is in terms of sine theta. The increasing and decreasing the voltage is a function of sine theta. So that it is called a sinusoidal waveform, sine waveform. From 180 to 360 degree, same thing repeated, but it's a negative cycle. So that positive and negative voltages are keep on changing, so that it is called a alternating quantity. Alternate means positive to negative, negative to positive, like that it will go. So due to that it is called as a sine wave, as a alternating quantity. We will see the some other waveforms, triangular waveform and rectangular waveform. This triangular waveform, it is in the form of triangle, so that is called a triangular waveform. From 0 to pi the voltage is positive, pi to 2 pi voltage is negative. That is voltage keep on increases, reaches the maximum value, then decreases, again reaches the max 0. The same thing repeated in a negative region, negative voltage. It is look like a triangular, so that is called a triangular waveform. Then we will go to the rectangular waveform. The graph drawn between time and voltage. From 0 to pi the voltage is positive. From pi to 2 pi the voltage is negative. So we will get positive voltage and negative voltage. So that is called a alternating waveform. It's look like a triangular. It's look like a rectangular. So that is called a rectangular waveform. So alternate means positive cycle and negative cycle keep on changes. We'll go for some more waveforms, sawtooth waveform and trapezoidal waveform. So sawtooth waveform, it look like a sawtooth, so that is called a sawtooth waveform. So here the voltage is maximum, then reaches the 0 value at 2 pi. Again from 2 pi to 4 pi the voltage is again maximum and reaches the 0 value. But here the voltage is always positive. So this is not a alternating quantity. This is a non-alternating quantity. Alternate means the positive and negative will change continuously. Positive cycle, negative cycle, positive cycle, like that. But here always we have positive voltage. So this is only this waveform is a non-alternating quantity. We'll go to the trapezoidal waveform. It looks like a trapezoidal. So that is called a trapezoidal waveform. 0 to pi we have positive voltage. So initially 0 increases, reaches the maximum value, then constant for some time, again decreases, reaches the 0 value. Same thing repeated in a negative cycle from pi to 2 pi. So we have positive and negative. So that's called a alternating quantity. So only this waveform is a non-alternating. The remaining waveform also are all alternating waveforms. Now we'll go to the remaining terms of the AC terminology. The remaining terminology we'll explain with this diagram. Now we'll consider the sine wave, sinusoidal wave. The waveform vary with the sine theta, so that is called a sine wave. It is sine 0, sine 90, sine 180, sine 270, then sine 360. Like that is keep on changes. The sine of theta, so that is called a sine wave. Is drawn between time period and voltage. See, at 0 degree the voltage is 0, then keep on increases, reaches the maximum value. It is here sine theta equal to 0 degree, here sine theta is 90 degree. In between it varies from 0 degree, 10, 20, 30, 40 like that. Thereafter again decreases and reaches the 0 again at pi 180 degree. Then same thing repeated in the negative cycle. Again the waveform increases in the negative region, reaches the maximum value, then decreases and reaches the 0 value at 2 pi 360 degree. So from 0 to pi 180 degree the voltage is positive. It's called a positive half cycle. From 180 to 360 we have negative voltage. So this is called a negative half cycle. The sum of these two, positive half cycle and negative half cycle, is the full cycle. The full cycle is nothing but sum of positive half cycle and negative half cycle. This is one cycle, changing from positive to negative. Positive quantity to negative quantity, completing the positive quantity to negative quantity from 0 to 360 degree is called a one cycle. In that we have two. Up to this is the positive half cycle because it is half of the waveform. So that positive half cycle. This is remaining half cycle. So negative half cycle. Right. So the cycle is nothing but completing one positive as well as negative voltage, that is up to 360 degree. In that we have positive half cycle and negative half cycle. So this is the nothing but time period. The time taken to complete one full cycle, that is positive as well as negative. The time t is nothing but the time taken to complete positive cycle as well as negative cycle, one complete cycle. The frequency, you know that frequency equal to 1 divided by t. The number of cycles per second that can be calculated 1 divided by t. T is nothing but time period. So what is amplitude? The maximum value is called the amplitude, where it is available at pi by 2, that is sine pi by 2, sine 90, we have maximum value. So this is the maximum value. Amplitude is nothing but maximum value. So here 0 then keep on increases, at this point only it reaches the maximum value. So that this amplitude is nothing but a maximum value. This value is nothing but a amplitude. Now we'll see this one by one. What is cycle, what is time period, what is frequency, what is mean by amplitude, everything we explained with the diagram. Now we'll see the definition. Right. Cycle is nothing but it is a set of positive and negative portion of the waveform. One cycle means it is the completing one positive cycle as well as negative cycle. Then what is time period? The time required for an alternating quantity to complete one cycle. One cycle means positive as well as negative. Is called a time period. Is denoted by t. The cycle is nothing but set of positive and negative. The completing this positive and negative is called a time period. Then we'll go to the frequency. Frequency is nothing but 1 divided by t. The number of cycles per second is called a frequency. So cycle means positive and negative. So completing one positive and negative per second. Within a second, how many cycles are completed is called a frequency. It is denoted by F. The unit will be cycles per second or in hertz, or it is called a hertz. F equal to 1 divided by t. Then amplitude. What is amplitude? It is a maximum value. We already referred in the diagram. The alternating means the positive negative changes, the value also keep on increases and decreases. In that maximum value of the alternating quantity in a cycle is called a amplitude. The maximum value is called a amplitude. Already we referred in the diagram. It is also called peak value or crest value. Peak value means peak means maximum. Now we'll go to the remaining terminology. The next term is the average value. What is average value? See, the waveform keep on increases, keep on changes from initially 0, then reaches the maximum value, again 0, again going to negative. So values keep on changing. Average value means we need to add all the terms from 0 to 360 degree. If you add all the individual values, that will give the average value. That is a general. In case of alternating, what is the meaning? The average value of an alternating current, here we refer the current, is defined as the DC current which transfer across any circuit the same charge that is transferred by alternating current during the same time. So the average value in general is nothing but by adding all the value divided by total will give the average value. Similarly here also same, but the definition is DC current to alternating current. Suppose the DC current is transferred across any circuit. The same charge as is transferred by alternating current is called a average value. Right? One circuit is available, in that DC current is passed. For the same time, what is the alternating current is passed for the same charge is nothing but a average value. So what is the formula? I average. Now we are referring current. Voltage also we can take. 1 divided by pi, 0 to pi I d theta for symmetrical. What is mean by symmetrical? Positive and negative. If you have positive cycle and negative cycle is called a symmetrical. Right? The positive cycle same thing will be available as a negative also. So this is the symmetrical waveform. Here we have positive and negative. If you put one line here, this both the sides are equal. This is positive, this is negative. So that is called a symmetrical waveform. So in that case we can take only one cycle, only one half cycle, because next cycle also same. Positive cycle is very similar to negative cycle. Only the thing is the polarity will change. Right? So that we will take 1 by pi up to 180 degree. The limit also 0 to pi I into d theta. So this is nothing but taking the average from 0 to pi, each and every value we are integrated, so that we will get average. In general, average mean I1 plus I2 plus I3 up to In divided by n. Like that here we are doing integration, so that we will get the average value. So a symmetrical waveform means positive half cycle and negative half cycle are equal. So we can take only one positive half cycle, only one half cycle. No need to take the full cycle. So that it is 1 by pi, 0 to pi I d theta. In case of unsymmetrical means it's not a alternating quantity. Right? So here we need to take full cycle. It may be is a non-uniform. So that we need to take full cycle 1 by 2 pi. 360 degree. 360 degree only the one full cycle. Here we are considering full cycle. Here we consider only half cycle, because next half cycle also very similar, symmetrical. So 0 to 2 pi I d theta for unsymmetrical. Right? If it is symmetrical, we can take only half of the cycle. If it is not symmetrical, we need to take full cycle. So what is the current waveform? Current, the expression I equal to Im sin theta. So this current is vary with the theta. If theta is 0, current also 0. Theta is 90 degree, 90 means 1. So current will be maximum. 180 means again 0. 270 means minus. 360 means again 0. So based on the theta value, the I will changes. This Im is nothing but the maximum value. Maximum value. That's called the amplitude. Maximum amplitude. So I equal to Im sin theta is the general waveform for a sine wave. The I varies with the function of theta. Now we'll go for this average value. We'll substitute this I as Im sin theta. Now we'll find the average value of the sine wave. So I average equal to 1 by pi, 0 to pi I d theta. Because of symmetrical, we consider only 1 by pi. So 1 by pi 0 to pi, I is nothing but Im sin theta into d theta. So this Im is constant, will take outside Im by pi 0 to pi sin theta d theta. So Im by pi, the integral sin theta is minus cos theta. That is, you need to substitute the limit 0 to pi. I will substitute the limit. So Im by pi minus cos pi. While substituting lower limit, one negative will be there. Already one negative is there, so it becomes positive. Plus cos 0. So cos minus cos pi, upper limit substituted, lower limit plus cos theta, cos 0. Here negative is there, while substituting lower limit, one more negative will be there, so it becomes positive. So Im by pi, the cos pi value is minus 1. Already one minus is there. Cos 0 value is 1. So that Im by pi minus minus become 1. 1 plus 1. So that's 2. So I average equal to 2 Im by pi. Right. So here 1 plus 1 2. So 2 Im by pi. That is nothing but 2 by pi is 0.637 Im. So the average value of current in a sine wave is nothing but 0.637 Im. But in average value, what is the disadvantage? We have one positive cycle and one negative cycle. If we add positive cycle and negative cycle, it becomes 0 because of polarity. One is plus, one is minus. So while adding these two, we will get 0. So for that, we can go to the root mean square value, RMS value. That is, the current is squared. While taking the square, what will happen? The negative become positive. Then we will take square root. So the originality will not change. Right. So in the average value, during positive half cycle, the voltage is positive, but during negative half cycle, the voltage is negative. If we add both, it becomes 0. So that we go for the root mean square value. We will see what is meant by root mean square value. So root mean square value, in order to avoid the average value becomes 0 due to positive negative, we will go for the root mean square value or effective value. That is, while taking the square, the negative become positive. Again we are taking the root, so it become normal. So what is the definition? The steady current which when flowing through a given resistor for a given time produces the same amount of heat that is produced by alternating current. When the current is flowing through the same resistor for the same time is called a RMS or effective value of an alternating current. Again the definition is, what is the definition? The current is flowing through a resistor for a given time. At that time heat is produced. For the same time and same current, what is the heat produced in the when the alternating current is flowing? So this is the definition. The current flowing through the resistor for a given time, heat is produced. For a DC current, what is the heat produced? And for the same, what is the heat produced for alternating current? That is the definition. Now we will see the waveform. We will see the equation. So again we have the unsymmetrical and symmetrical. Symmetrical mean we can take 1 by pi, only half cycle. Unsymmetrical mean we have to take full cycle, 0 to 2 pi. So here what we are doing, I RMS square equal to I square. Here taking I square. If you take square, what will happen? During positive half cycle, the current is plus I. During negative half cycle, the current is minus I. But while taking square root, it become positive. So it will not 0. Plus I and minus I will not 0. Both it become positive. So that we are taking square. So the negative term will be converted into positive while taking square. But again we are taking the, here also we are taking square, or we can take square root, so that the originality will not change. So here what is that? 1 by t 0 to t I square dt. This is a general term. T is nothing but the time period. It may be 2 pi or pi, or t by 2 means half cycle. So this is a general formula. The t may be 2 pi or it may be pi. Now we'll go to the alternating quantity. We'll see the RMS value. So I equal to Im sin theta. We already discussed. So I square RMS. So we are here that square is done on both the side. So the negative become positive. 1 by 2 pi 0 to 2 pi I square d theta. But here only we have 1 by pi is enough, right, because it is a symmetrical value. So 1 by pi 0 to pi I square d theta. So 1 by pi 0 to pi I square is Im square into sin square theta d theta. This Im square sin square theta into d theta. Now we consider only half cycle because it is symmetrical. The sin square theta, before integrating we need to change it. So the sin square theta is written as 1 minus cos 2 theta divided by 2 into dt. This Im square is taken outside because of constant. So Im square divided by pi integral 0 to pi 1 minus cos 2 theta divided by 2. Sin square theta is now changed into 1 minus cos 2 theta divided by 2. Now we can easily integrate this. This 2 also taken outside. So Im square divided by 2 pi into the integral 0 to pi 1 minus cos 2 theta into d theta. Now we need to integrate this. We'll go refer here. I RMS square equal to Im square divided by 2. So the integral 1 is, that is d theta. Integral d theta is theta. Integral cos 2 theta is sin 2 theta divided by 2. Right? These two terms are integrated. Now we'll substitute the limit. First substitute the upper limit pi. So theta is pi minus sin 2 pi divided by 2. Then substitute the lower limit. At the time negative will be there, minus 0. Here already negative is there, so that become positive, sin 0 by 2. So pi minus sin 2 pi by 2 minus 0 plus sin 0 by 2. So the sin pi is 0, sin 0 also 0. Only we have pi. So Im square divided by 2 pi, pi minus 0. That is Im square divided by 2, only pi is available. This pi got cancelled. Right. So what we have, this Im square divided by 2. Im square divided by 2. Now we'll take the square root on both the sides. So that I RMS equal to Im divided by root 2. This Im square become Im, 2 become root 2. So the 1 divided by root is nothing but 0.707 Im. Right. The numerical value available. So I RMS equal to 0.707 times of Im. Now we'll go to the next parameter. So the next is the form factor. There are two factors available, form factor and peak factor. Form factor, what is form factor? It is the ratio of RMS value to average value of an alternating quantity. So this is one reference. What is the ratio between RMS value and average value? It is the ratio of RMS value to average value. For sine wave, we already calculated what is the RMS value and average value. Just now we got the derivation. What is the RMS value and average value? Now we'll substitute. For sinusoidal waveform, form factor equal to RMS value by average value. Now we calculated RMS value is Im by root 2. Average value is 2 Im by pi. Right. So that it is Im by root 2. While going to numerator, it become pi divided by 2 Im. So this Im got cancelled. What we have? Pi divided by 2 root 2. So by simplifying this, which is nothing but 1.11. So for a sinusoidal waveform, the form factor is 1.11. So these two values we already calculated, that is substituted. After simplification we got. So form factor of a sinusoidal waveform is 1.11. Then we'll go to the peak factor. One more factor is available. It's called a peak factor. So it is a ratio of peak or maximum value to the RMS value of an alternating quantity. So it is a ratio between peak value to RMS value. For again we will find the for sine wave. For sine wave, the peak value is Im. The RMS value we already calculated, Im by root 2. So while going to numerator, what will happen? Im into root 2 by pi. This Im by root 2 become root 2 by Im while going to numerator. So Im got cancelled. Only we have root 2. So the root 2 value is 1.41. So the form factor, so this is not a form factor, it's peak factor. It is a peak factor for a sinusoidal waveform is 1.41. The form factor is 1.11. The peak factor is 1.41. So in this video we discuss about the AC terminology, starting from waveform, cycle, time period, everything. Then we discuss the average value, RMS value. Then two different factors, form factor and peak factor. Thank you.